In my previous video, I explained to you about the symmetry elements and symmetry operations which are used in a molecule. In this video, I will be explaining you about the order, subgroup, class, how to draw the multiplication table, and what are the various point groups in a molecule, or you can say molecular point groups. Order tells you about the number of symmetry elements which are present in a group. Let us consider an example of water molecule. It is having 4 symmetry elements, so order will be 4. Subgroup, it is the smallest part of the group which follows the 4 group postulates which I have discussed earlier also, that is closure, associativity, inverse and identity. When we talk about a class, it is a complete set of elements that are conjugate to one another within a group is called a class of the group. Or you can say group can be further divided into smaller sets which are known as classes, and they follow similar transformation. Now I will be discussing how to draw the multiplication table. First I will be drawing C2E multiplication table. Example is water. Now in this, if you see, it is having 4 symmetry elements: E, C2, sigma xz, sigma yz. So that I have written on either side. Now multiplication with E will be giving you same molecule, that is E into E is E, then E into C2 is C2, E into sigma xz is xz, and E into sigma yz is sigma yz. Similarly here, E into E is E, E into C2 is C2, E into sigma xz is sigma xz, and E into sigma yz is sigma yz. Now let us come for C2. C2 and C2, that will be giving you what is known as identity E. Now let us do it. I am taking a water molecule. I am giving 180-degree rotation. It will flip HBA, and then again I am giving 180-degree rotation. You will get HAOHB. Now these two are identical, so this is nothing but the identity. That is why I have written here identity. Just to remember it, you can write diagonally also. You have to write it is E. Now C2 and sigma xz should give you sigma yz. Let us do it. HAOHB, you are applying a plane, sigma xz plane. It is giving you HB OHA. It is equivalent to this. Now to the same molecule you will be applying 180-degree rotation, and it is giving you HAOHB, which is similar to this. Now in this, if you are applying a YZ plane, nothing will happen. You will get the same molecule back. If you compare this with this, they two are same. So C2 sigma xz is giving you sigma yz. That is why I have written over here C2 sigma xz is sigma yz. Now C2 sigma yz will give you sigma xz. That is this. This is the direction of operation. HAOHB, sigma yz plane, you are getting same molecule back. Then C2 rotation you will be applying, you will get HBOHA. To the same molecule, if you give sigma xz plane, this will flip. It will give you HBOHA. Now these two, they are identical. So sigma C2 sigma yz is nothing but sigma xz. C2 sigma yz is nothing but sigma xz. Now once you have solved this two, the remaining you can do, because sigma xz C2, this we have already done, it is sigma yz. Sigma xz will give you identity. Sigma xz sigma yz, this I will solve. You should get C2. Sigma xz sigma yz. Let us solve this. First I will be using sigma yz plane. You will get same molecule here. Then sigma xz plane, they will interchange their position. You will get HBOHA. Now to the same molecule give C2 rotation. Again you are getting HBOHA. That is, so sigma xz sigma yz is nothing but C2. So this is how the multiplication table for water molecule is drawn. Now let us come to the multiplication table for ammonia. That is, it is showing C3. These are the elements E, C3 plus, C3 inverse, sigma V1, V2, sigma V3. Same same things will be written over here. Now with E you will be getting same, because E is working as number 1 in multiplication table, and this side also you will be getting same. Now let us start solving from here. That is C3 plus and C3 plus. You should get C3 inverse. Now let us solve here. I have written ammonia, C3 rotation, that is 120-degree rotation if you are giving. So this will come here, H2, this will come here, and this will come here. So you will be getting this molecule. Again C3 rotation, H3 will shift here, this will shift here, this will shift here. You are getting this molecule. Now to this molecule, if you are giving inverse rotation C3, H1 will come here, 3 will go here, 2 will come here. Now this and this, they are identical. So C3 is nothing but C3 inverse. So this is how C3 and C3 I have written C3 inverse. Now C3 plus and C3 minus, it is giving you E. Let us find out how you get this. This is ammonia molecule, C3 rotation you are giving, they will interchange their position. You are getting this, and then again give reverse rotation. So this will come here, this will come here. You will get this molecule. Okay. So this is nothing but similar to this only. So that is E. That is why in the multiplication table I have written E. Next is C3 and sigma V1, that is giving you sigma V3. Let us do it. C3 sigma V1. Sigma V1 means we are applying this plane over here. So when you are applying plane over here, this two, they will interchange their position, H2, H3. Now in this you are applying C3 rotation, 120-degree rotation, H1 will come here, H2 will go here, and now this is nothing but it is equivalent to sigma V3. V3 plane, if you see, you will be applying over here. V3 plane, sigma V3 plane. When you apply here, this two will interchange their position and you will get the same molecule. This is how it is solved. Another is C3 plus and sigma V2 giving you sigma V1. Now first, this is the direction of operation, sigma V2 plane you will be applying. So when you apply sigma V2 plane, they will interchange their position, and then to same you will be applying C3 rotation. So you are getting this molecule, and to this molecule when sigma V1 plane you are applying, sigma V1 plane means along this plane you are applying. So H2 and H3 will interchange their position. So these two are identical. So C3 plus and sigma V2 is nothing but sigma V1. So this is how the multiplication table for C2V and C3V, they are drawn. Now I will be discussing with you various point groups, how to find out the point group. Point group, it is nothing but the collection of symmetry elements which are present in a molecule. So molecular point group means you will be finding all the symmetry elements which are present in a molecule. They are denoted by Schoenfly symbol, and total there are 32 symbols. So I will be discussing one by one. For convenience, I am dividing it into low symmetry and high symmetry point groups. Low symmetry includes C1, CS, Ci. C1, that is only E, CS is E plus sigma H plane, Ci E plus I. High symmetry, it includes D infinity H and C infinity H. Besides that, there is high symmetry cubic groups which include TD, O, H and IH. So let us discuss them one by one. First, I will be discussing C1 point group. It is having only E. So all the 4 substituents will be different. There is no other symmetry in this. It is having only identity. Second is CS point group. It is having E plus any one sigma. Sigma, it can be sigma H, sigma D or sigma V. So here I am considering it is having E and sigma H plane. Same example you can consider this also. It is having E and sigma H plane, that is horizontal plane. Then is CI. It is having identity and inversion. So this is the center of symmetry. If you reproduce line from either side, you will meet the same group. Then comes CN. CN will be having first identity and second CN axis of symmetry. So C2 I have taken hydrogen peroxide. It is having C2 axis plus E as the element of symmetry. In case of E plus C3 axis 120-degree rotation, you will be giving CS3, CF3. Then CNV point group, if it is having CN plus sigma V. That is, if I am considering C2V, it will be having E2, C2 and 2 sigma V rotation. Example is of water. For C3 V, example can be PCl3 or NH3. Now let us come to the high order symmetry, which includes sigma infinity V. All the linear molecules, they fall in this group. Example HCl, HBr. So it will be having identity C infinity and infinity sigma V axis. Then is DN. DN will have n-fold principal axis and n2-fold axis, which is perpendicular to the principal axis. In case of DN, you will say if it is having horizontal mirror plane, then it will be DNH. If it is having dihedral mirror plane, then it will be DND. DNH example I have taken D2H. Example is alkene. So it will be having E C2 and C2 perpendicular to 2 C2 axis and sigma H. And DND I have taken D2D. Alene I have taken. It is having identity C2 axis perpendicular to 2 C2 axis and 2 sigma D and 2 S4 axis also. Besides this, there are other point groups of higher order. For example, SN, it will be having E plus SN axis. Example is CO4, CP4, where CP is cyclopentadienyl ring. TD is tetrahedral. Example is methane. OH is octahedral. Example is SF6. And IH is icosahedral. Example is full ring. Now this was all about the point group. Now if any molecule is given, how you will be identifying it? There is one decision tree which will be telling you about it. So whenever molecule is there, look for low symmetry group. If they are present, it can be C1, CS or CI. If it is not present, look for high symmetry group. If high symmetry group is present, it can be TD, IH, OH, C infinity V and D infinity H. If high symmetry group is also not present, then look for the highest order rotation axis CN and then see whether it is perpendicular. If it is perpendicular, then you will be looking for D group. If it is not, then you will be looking for C and S group. Now in C and S group, you have to see whether it is having sigma H plane. If it is having, then it is CNH. If it is not having, then look for sigma V. If it is having sigma V, it will be CNV. If it is not having, then look for S2N. If it is having S2N, element of symmetry, then it will be S2N point group. If it is absent, then it will be CN. Similarly in D also, sigma H plane is there. If it is there, it will be DNH. If it is not there, look for sigma D. Yes, if sigma D is there, then it will be D and D. If not, it will be DM. So one example I will be considering of benzene. So it does not belong to low symmetry and high symmetry group. So we have looked for the rotation. It is having 6 axes of rotation. So it is C6. C6 is perpendicular to the principal axis, so it is D group. And in D group also, since it is having dihedral, so that is why it is having D6H. It is having horizontal plane, so horizontal mirror plane, so sigma H is there, so it is belonging to D6H point group. So this is how we find out what point groups are present, and systematically we have to approach. So these point groups, they are well explained by Schoenfly symbols. Total, as I told you, there are 32 symbols. Schoenfly, it is notations, they are named after the author, Mortis Schoenfly, and he has denoted it by a letter symbol with a subscript. For example, the letter O is used for octahedral, and it indicates the group has symmetry of octahedral, and OH, or without improper rotation, it will be O. The T is for letter tetrahedron, that the group has symmetry of tetrahedron. TD includes improper rotation. T dash excludes the improper rotation. I is for icosahedron. IN is without improper rotation, improper rotation, and I is without improper rotation. Similarly, CN is for cyclic, and it indicates the group has n full rotation axis. CNH means CN with addition of mirror plane perpendicular to the axis of rotation. CNV is with addition of mirror plane parallel to the axis of rotation. SN rotation reflection axis, and DN is for the dihedral. So this is how I have grouped them. CS symmetry element will be 1 sigma, CI 1 I, CN 1 CN, DN means 1 CN and N C2 perpendicular to CN, CNV means 1 CN and N sigma V, CNH means 1 CN and 1 sigma H, DNH means DN plus sigma H, SN1 SN, TD tetrahedron, OH octahedral, icosahedral, and H is for sphere. So this is all about the various molecular point groups and how to identify them. Now in my next video I will be explaining the matrix. Thank you.